Hello, and welcome to everyone. Welcome to our webinar. This is a sequence of webinars organized by Eötvös University. We try to arrange this sequence of meetings in order to show you some of our programs, and today's event is scheduled to be about programs in mathematics. This is actually the 16th of webinars in our sequence. So I should also mention that if you miss some of the webinars and you would be interested in some of the past events, you can watch the events because the events are recorded. And so you can find it on the YouTube channel of the university. You will get information about it after the event, how you can get back to see these events from the past. Also, this event will be recorded. So I'm very glad that you could join us. I hope that the information provided here will be helpful in deciding whether to come to Budapest or not, or for those of you who already have intention or maybe have already passed the entrance examination, we will provide some information about our programs, which was not obvious until now. So let me just first introduce the hosts of today's event. My name is István Ágoston. I'm teaching algebra at the Department of Algebra Number Theory. My specialty is ring theory and representation theory. I'm also the international coordinator of the Mathematical Institute. And besides that, I'm the head of the program committee of the master's program in Eötvös University. So I will be your principal host for today. Our second host, let me just turn to him now, is Professor András Zemplényi. He is the chairman of the Department of Probability and Statistics, and he is also our former vice director of the Institute of Mathematics. And he is the coordinator of one of the important courses in our master's program, among others, of course, because he teaches a lot of courses. But this course is called the modeling work or project work. I don't know precisely the title. We will come to that later. So he's the coordinator of this course, which is, I think, quite useful for our students in applied mathematics. So hi, András, I'm glad that you are with us.
Thank you very much for inviting me, and I'm really pleased to answer any questions, mostly regarding to applied maths programs, which is my specialty.
Okay. Actually, I should add that Professor Zemplényi will be working behind the scenes. Answering questions will be done via the chat dialog boxes, and Professor András will just retire from this publicity of the camera, and he will answer your questions in the chat box. So please put your questions in the chat, and if possible, he will answer your questions. If there are some questions for which we do not have the answer now, we will try to come back to you later. Those questions which are of public interest will be posted in the public chat box. Okay. So the third host is Miss Lydia Mirabel Mendoza Cadena. Hi, Lydia. I'm glad that you could accept our invitation. Could you just introduce yourself?
Yeah, hello everyone. I am Lydia. I am from Mexico. Well, I studied my bachelor in actuary at Mexico, and after that I really like the operation research area. So I got very interested in continuing studying, and I got accepted into ELTE in 2018. So I got my master in sciences here. I just obtained it last year, and after that I just really like here. So I applied to get my PhD here at ELTE too. So now I got a position as a research assistant at Eötvös, which is the group in operations research area. Well, I would like to be a researcher someday, either in the academy or in a private company. So that's what I want to say about me.
Well, thank you once more for being with us. Occasionally, from time to time, I will turn to you because there are some questions which are perhaps more better explained by you than by me. But I must admit also that I remember when you first came to my office, I was in some sense surprised with your determination that you had a completely clear vision of what you want to do. And you said you want to do operations research, and you did perfectly that. So I'm glad that you are with us. I'm also glad that you could join the PhD school. So we shall continue with our meeting now. The fourth host is Miss Eva Nagy. I'm thankful to Eva that she could join us. She is in the middle of the busiest week of her life, I think, at the university. Hi, Eva. I'm glad that you are here.
Hello, everyone, and thank you for having me. It is indeed very busy, but that is a good thing, actually. So let's.
Okay, so I should add that Eva will be the host of a second set of slides because she will speak more about the entrance procedure and what you should do officially if you want to apply. So this is the second part of the talk. Perhaps in 45 minutes, we will come to that. Okay, so András, if you wish, you can switch off your camera, but please feel free to return anytime if there is something that you want to add. So what I would like to start with is a little guided tour of Budapest. Unfortunately, traveling is a little bit limited nowadays, but let me just guide you through some of the places in Budapest, because Budapest is really an interesting city. It is, as it is said, the city of spas and thermal baths. Probably you would be surprised that in Hungary, which is not really on any volcanic territory, there are over 1,000 wells with thermal water available. And already 2,000 years ago, people started to build baths around these wells. So Budapest is, in this sense, really abundant in thermal baths. As you can see, there are these three baths which I have chosen randomly. Of course, they are quite famous. The bath, Széchenyi thermal bath, is in the so-called city park, which is one of the recreational areas of Budapest. And as you can see, there is a historic building around it. The Palatinus bath is an open area bath on the Margaret Island, another favorite spot of people from Budapest, while the Gellért thermal bath is adjoining one of the historic and most exclusive hotels, there's a Hotel Gellért in Budapest. I should mention perhaps that the tradition of baths was also enhanced during the Turkish era. In the 16th and 17th century, Buda was under Turkish rule, and Turkish rule brought with it also some building of very nice baths. So many of the baths carry the Turkish influence. Now, Budapest is also known for its theaters and concert halls. I could say that this so-called 6th and 7th district is the theater district of Budapest, but there are many other places around the city with smaller or larger theaters. But this is traditionally the theater district. And here in this area is located the Opera House, for instance, which you can see on the bottom, which was built around the turn of the 19th century in 1884. I think it was officially opened. And it was built by one of the most famous Hungarian architects. And one of the first directors was Gustav Mahler. He was an Austrian composer, very famous, again, around the turn of the century. He, I think, spent something like almost 10 years in Budapest. The other spot is the Liszt Academy. Originally, Franz Liszt, when he was already at close to 60, then he spent more and more time in Budapest, and then there was this idea to build an academy of music for him. So this academy was opened in 1875, I think, if I'm not mistaken. The building itself was finished in 1907. And the first president of the academy was Franz Liszt himself. So he's a famous composer from the Romantic era. So these two are more traditional buildings, recently renovated. What you can see on the top is two new buildings built already in the 21st century. The National Theatre was opened in 2002, and the Palace of Arts, this is with the blue or pink or violet colors. This is the Palace of Arts. This was built some 4 years after that, or perhaps 3. They host the theater events or concert. In the Palace of Arts, you have a major concert hall. So most of the famous or most prestigious concerts happen either at the Liszt Academy or in the Palace of Arts nowadays. Okay, so what else is Budapest famous for? Budapest is also hosting some major sports events. As you can see, the Budapest Marathon, which unfortunately nowadays cannot be organized, or it was not organized for the past 2 years, but the Budapest Marathon is a favorite event for both people from Budapest and for people from outside. Many people from international community come for this event. Tens of thousands of people run on the streets of Budapest on this event. But also events like the World Swimming Championship in 2017 or the Fencing World Championship in 2019 brought with them many famous participants from all countries of the world. The next event will be some matches of the European Championship in football. So in this respect, we cannot really complain. We just wish everything comes back to normal soon. Okay, so sports events are also part of the city. Budapest is also the city of UNESCO World Heritage Sites. The city was, some of the parts of the city were declared to be part of the World Heritage, like, for instance, the banks of the Danube with the Parliament building on the Danube. This is one of them, or the Castle District with the Buda Castle. This is the other one. This is the evening lights of actually, they are on opposite sides of the Danube river. And the last picture shows the Andrássy Boulevard. This is one of the major boulevards in Budapest, built for the Millennium celebration. So this monument that you can see here is the so-called Millennium Monument. Millennium, the name Millennium comes from the fact that, according to historic sources, the Hungarian tribe settled in this area in 896. So 1,000 years after this event, there was a celebration of the statehood, 1000th anniversary of the statehood. And at that time, they built a lot of new buildings. They reconstructed Budapest, as I should say, in many respects. And this brought with it also some kind of economic revival. So this is why we have this Millennium Monument with statues of Hungarian kings and some other rulers, important people in these buildings. Okay, so UNESCO World Heritage. But not only UNESCO World Heritage, but there are also universities, and probably this is what you are interested in. So the top picture is the main building of Eötvös Loránd University, the Faculty of Law. Our university is the home to many sciences. So like natural sciences, humanities, law, and economics are hosted by this institution. And this is the oldest institution in Hungary. Oldest in the sense that it was established in 1635. There are a couple of universities which were older than ours, but they ceased to exist after 10, 15, or 20 years or 50 years. So this is the oldest continuously existing university. And with its 33,000 students, this is the largest university. Now, in the middle picture, you can see the technical university. Actually, it is just next to our building, but Technical University was established in 1782, and it hosts studies in engineering, mostly architecture, chemical engineering, or electrical engineering or informatics. But they also started their own education in natural sciences. So they have, for instance, programs in mathematics and in physics. Then one of the youngest universities is the Corvinus University, which is specializing in economics. 1920 it was established with 18,000 students. But I should also mention that we have a joint program with Corvinus University in financial mathematics. Unfortunately, this is not available still in English, so this is just for local students. And on the left, you can see the picture of the main building of Faculty of Medical University, this Semmelweis University. Originally, it was established as a faculty of Eötvös University, but then it separated in around the 1950s, and it became a university on its own. So I think with its 11,000 students, a lot of them from international community, this is also one of the major universities. On the other hand, let me just mention that besides these four important institutions, there are more faculties specializing in arts or specializing in economy. So altogether, there are over 20 institutions of higher education. And they carry with them 150,000 students. So the number of students in Budapest is something like 8 to 10% of the population of the city. Perhaps it's 8% of the population. Okay, so let's come a little bit closer to our university. You are all aware of the geographic location. We are in the middle of Europe, and Budapest is in the middle, a little bit to the north of than the middle of Hungary. So this is where all, or not all, but most of the programs are done at Eötvös University. We call it ELTE, for occasionally I will just call it ELTE. This is a shortening for Eötvös Loránd and then university translated in Hungarian. So this is the TE. So Budapest is, as you can see, the capital of Hungary. As you can see, this is on the shores of Danube. Let me just give you some figures about the university. As I said, it is the oldest university in Hungary. It was established in 1635. And with a precise number of 33,307 students, this is a data from 2020, it is the largest in Hungary, with over 3,000 international students from 109 countries. So as you can see, a number of international programs is running, and close to 2,000 students are in their PhD studies in various doctoral programs. So we have 16 doctoral schools, among them the doctoral school in mathematics. The structure of university is such that it is divided to 8 faculties and 2 other study units. I will just come to this in a minute. We have 14 dormitories for 4,700 students, and we have a wide web of international connections. So the international connections are relating to us, related to close to 500 various universities. And these various universities are either tied to us via bilateral partnership contracts or by Erasmus. These are multilateral agreements. And besides this, we have 52 BSc programs and 112 master level programs, 17,000 courses. So if you just think about these numbers, I think they are quite impressive. Our Eötvös University, or ELTE, is usually considered as one of the most prestigious universities in Hungary. And the reason for this is partly due to the fact that the qualification of the teaching personnel is quite high. So 83% of lecturers have scientific degree. And I should say that perhaps the rest, the remaining 17%, consists just of PhD students who are working on their degree, first degree. So in principle, the level is considered to be high level of education. 72 members of our staff are the members of the Hungarian Academy of Sciences. This is the most prestigious scientific body in Hungary. So 20% of the academicians are related to our university. We usually speak about 5 Nobel Prize laureates among the alumni. These, of course, they worked in physics and in medicine. I don't want to list them, but what I should mention, and I will come back to this in a minute, but I should mention also here that we also have some Abel Prize laureates, because Professor Loránd, who is a professor emeritus at our university, just recently won the Abel Prize, which is considered by many as a Nobel Prize of mathematics. And to illustrate the level of research done at the university, there are over 70 research groups at the academy, joint research groups with the academy or independent research groups. There are some research groups tied to the European Union. So this is why Eötvös University won the title of a research university. And okay, so just one short piece of information. What is the name Eötvös Loránd? What is behind the name of Eötvös Loránd? Loránd Eötvös was a physicist. He was a Hungarian physicist, and his work on gravitation is well known. He invented the torsion balance, and this is the instrument that you can see on the picture, which was used to check distortions in gravitational field. So this is why it is used in mineral and oil industry, but it was also instrumental in proving the proportionate character of the gravitational inertial mass. So this is one of the experimental proofs of the general theory of relativity. But interestingly enough, Eötvös Loránd was also a minister of education for a very short period, for 7 or 8 months. But during these months, he managed to establish 400 new schools in Hungary. So he really considered that establishing schools in small places and in countryside was important for the nation, for the country. Okay, so let's get back to the structure of the university. As I said, we have 8 faculties: Faculty of Education and Psychology, Faculty of Humanities. Perhaps I should not read all this, but as you can see, a wide variety of topics occurs among our programs. Faculty of Science, where mathematics is part of, or mathematics is part of this faculty. This is the second largest faculty, principally in the number of students. And I think this is one of the 3 traditional faculties of the university. There are some new faculties. Now, of course, I forgot to mention these 2 special teaching units. Institute of Business Economics is just now in the process of becoming a faculty, but this is how some other faculties joined us or became independent. For instance, Faculty of Informatics was part of Faculty of Science until 2001, I think, and then this is when they became independent faculty. If you become a student at Eötvös University, you will be free to take courses in any of the faculties. Of course, the program will give some limitations. So if you come to a program in mathematics, you can take free credits in history, for instance. But of course, in some sense, you do not have so many free credits. You should concentrate on mathematics. But I'm saying this, that there is a possibility, especially for interdisciplinary connections, like you would be interested in informatics or or physics, then you will have a chance to also take courses there. The guided tour will continue with showing some faculty buildings. On the top, you can see Faculty of Law. This is the place of the central administration, not really the administration, but the central leadership of the faculty. So the rector has a place here. But this is in the center of the Pest part of Budapest. And this is really the historic part of Budapest. And next to it is Faculty of Humanities. Next to it means 3 minutes walk from there. Faculty of Humanities. Both buildings were built something like 130, 40 years ago. Faculty of Humanities is located next to the National Museum. So it has a campus, a larger campus with more buildings. This is one of the main buildings of Faculty of Humanities. To the left on the bottom, you have 2 buildings of faculties of science, but also Faculty of Informatics and Faculty of Social Sciences is located in this building, in these 2 buildings. These are new buildings built and completed in 2001. So these are relatively new. Something like 20 years ago, less than 20 years ago, we moved into Faculty of Science, this left building, what you can see in red. Besides these faculties, let me just show you as a curiosity, we also have Botanical Garden, established in 1771, and the University Library, which was established before the university. It was in 1561. Later it was joined to the university, and of course this building was built around the turn of the century, 19th century. So the building is not that old, but the library itself is quite old, with more than, I don't know, 2 million volumes of books. Okay, so let's go now to more concrete places, and this is Faculty of Science and Institute of Mathematics. As you can see now, you have a better view of the 2 buildings. The left one is where Faculty of Mathematics, Institute of Mathematics is located. The northern one, we call it the northern one, is equipped even with an astronomical observatory. On the top of the building, you can see this sphere. And this classroom, which you can see, is part of Institute of Mathematics. The picture was taken on one of our summer schools, international summer schools. So if you come to mathematics, most of the time you will be sitting in classrooms like this, because the big lecture halls are had for those who have large classes. Usually in the BSc program or in biology, they have large classes. So the classroom size shows also the size of the classes that you would attend. These are usually for 20 or at most 25 students. Okay, now let's see a little bit about the mathematical tradition of ELTE. On the picture you have 5, I'm not really saying randomly selected mathematicians who have some ties to university, but all of them are well known and have ties to the university, either by having been a student of the university, like John von Neumann or Paul Erdős, or because they had a position at the university. For instance, Friedrich Ries thought during the last 10 years of his year, he had a professorship at the university. He is well known for his work in function analysis. He is one of the people who established function analysis, or Lipót Fejér, who for more than 40 years was a professor of the university, and he's known for his work in Fourier analysis, or Paul Turan, a number theorist, or his work in graph theory is also important. Now, John von Neumann is known, I think, for everyone, because he's well known for his mathematical foundation of both of quantum mechanics and of computer science. And of course, everyone knows Paul Erdős. He is the traveling ambassador of mathematics. And he has over 1,500 papers, mostly joined with some other people. He basically was one of the most important figures in the Hungarian mathematics of the 20th century. He has contributions in number theory, in combinatorics, in graph theory, in geometry. So basically, when he died in 1996, a report about his death appeared on the first page of the New York Times. So this shows that partly because of his mathematical importance and also because of his interesting lifestyle, he was well known everywhere. But of course, this is our past. Let's go back to our present, or let's go to our present, not back, but let's go to our present. Let me just show you pictures of some more recent members of our university. Professor Lovánd, I mentioned his name, is the recent winner of Abel Prize. It was just announced a month ago that he was the winner together with another scientist from the United States and Israel. But he's the winner of the Abel Prize. This is one of the most prestigious mathematical prizes awarded, considered very often as a Nobel Prize of mathematics. Let me just also add that he also won the Wolf Prize. This is the second in the sequence of very prestigious mathematical prizes. So he's one of the few who was awarded by both of these prizes, and he has many other prestigious recognitions. He was also the president of the Hungarian Academy of Sciences, and he was also the president of the International Mathematical Union for some time. Professor Szemerédi, who is not a professor at ELTE, but he was a student at ELTE, he is also a winner of Abel Prize from 2012. Actually, both of them are combinatorists, work in combinatorics, and both of them have a lemma named after them. There is the so-called Lovánd local lemma and the Szemerédi's regularity lemma, which somehow speak about some order in random graphs. And I think some people say it's more important to have a lemma named after you than a theorem. Both of these lemmas became instrumental in this part of the combinatorics. So Professor Babai is well known. Some 5 years ago, he came up with a proof, a very important statement that the graph isomorphism problem is solvable in quasi-polynomial time. This is one of the important search problems, and this is perhaps the one of the most important events happening in algorithm theory in the recent years. Professor Lackovics is known for circling the square or squaring the circle because he solved a long-standing problem of Tarski called the circle squaring problem. So there are many famous names tied to the university who either had professorship at the university and some of them still teach here, or were students of the university. By the way, Lydia, you are with us. Let me just ask you, did you have any chance to meet any of these people, or since you are in discrete mathematics, did you have a chance to meet some other important people?
Well, I remember when I was master's student, I took a course. It was more like a seminar in large networks. So this course was led by Professor Lovánd, also by another important figure in complex networks, who is Professor Albert Laszlo Barabasi, and it was also led by Professor Jaroslav Nesetril. So it was a really, really nice seminar. I enjoyed all the talks. Unfortunately, I didn't have the opportunity to meet with Professor Lovánd, but I met with Professor Barabasi. But I've been reading material of both of them, and they are like nicely written. So yeah, that's like the connection that I have.
I remember when this event was advertised, and I think that many people from outside the university participated. So it was not just a student event, but it was an all-nation event in some sense in mathematics, because I remember people coming from the Rényi Institute, Research Institute, in their not students, but having position at the Rényi Institute. They participated on this event. Thank you. So having met these people, let's turn back now to our slides and let's see the next slide, which is about the structure of the Institute of Mathematics. We have 8 departments. As you can see: algebra and number theory, analysis, applied analysis and computational mathematics, computer science, which is a cover-up for combinatorics and discrete mathematics, then geometry, operations research, probability theory and statistics. And we have a department which is not called a department, but it is called Mathematics Teaching and Education Center, but they teach and they work in didactics of mathematics. So as you can see, most important areas of mathematics are covered by these departments. In principle, the size of the departments varies between 7 to 8 people and to 15, but altogether this brings to the number of staff members to over 80. Let's get to the programs in mathematics at ELTE. I listed 6 programs, but out of these 6, let's just go to see number 3, 4, and 6, because these are available to international students. The other one, for instance, BSc program, this is in Hungarian only, available to international students who come and learn Hungarian first. But the programs 3, 4, and 6 are English, entirely in English, so these are readily available to everyone. The master's program in pure mathematics, the master's program in applied mathematics, they are 2 years programs, and the PhD program in pure and in applied mathematics and in teaching of mathematics, this is a 4 years program. Sorry, let me just, I'm having difficulties in getting to the next slide. The master's program in pure mathematics. This is, as I said, a 2 years program, and it consists mostly of coursework. So you have to obtain altogether 120 credits, and out of this 120 credits, you get 100 for credit works. You have 6 credits for direct research, and the typical course is something like 2 hours lecture and 2 hours of practice. Sometimes you have courses without practice. Sometimes you have courses without lecture. These are practical courses mostly. I shall speak a little bit more about the directed research. This is aiming to bring students into research already at this time. The courses are in 7 subject groups: algebra, number theory, analysis, discrete mathematics, geometry and topology, operations, research, and stochastics. And in order to ensure the diversity of the education that we give to our students have to choose from at least 4 different subject groups. But the selection of the courses is quite free. And the number of courses is really enormous, so you can choose from over 120 courses. Let me just show you on an example a course selection of someone who was specializing in algebraic geometry and differential topology. He took courses, many courses in algebra, like for instance, algebraic number theory or chapters in ring theory, commutative algebra, Lie algebras, these rings and algebras. This was, or perhaps there was also groups and representations. These were courses in algebra. He took many courses in differential topology or differential geometry. So algebraic curves was algebraic geometry, or complex manifolds, this is slightly related. Differential geometry of manifolds is related, or Lie groups is related, or Riemannian geometry is related. But he also took courses in analysis not related to this, for instance, topological vector spaces and Banach algebras. This is one such course. This student is at present in his last year of PhD studies in algebraic geometry at ELTE. Another possibility for courses is the selection of someone who was specializing in discrete mathematics and optimization. I think that at the time he started his studies, he wasn't sure really of what type of mathematics he was interested in. He was interested in many things. So he started with courses in algebra. So he took a lot of courses in algebra. Then he took courses in set theory. He took courses in combinatorics. He took courses in probability theory. But then he basically settled with optimization, combinatorial optimization. So he took some courses in combinatorial algorithms, or algorithms 1, as you can see. So again, this just shows that you can come to the program with a already established decision that, okay, you want to work in this area, but you can also wander around for a while and choose from a number of courses to figure out what is the most important for you, what is the most interesting subject group to you. I wanted to speak something about the course Directed Studies. Directed Studies is aiming to help students in writing their thesis. And also, since students in pure mathematics usually continue their studies, to direct them into a research. So this course, Directed Studies, it lasts for 2 semesters. And this is typically to work on an open problem, or you can also learn something that is otherwise not available at ELTE. The examples from last fall, for instance, there were some results on new quantum algorithm in group theory, for instance. I just heard the talk of the student who presented this. Sorry, I'm losing my voice. Or one of the students got some convergence results for strongly stationary non-negative ergodic sequences, as you can see. Or we got a nice result on complex manifolds, some new results in combinatorics and external set theory. So I think that the Directed Studies was quite useful for these students. Okay, sorry. Unfortunately, yes. As I said, the Directed Studies introduces you to diploma work. You have to write a thesis for your diploma. And I just listed a number of diploma works here on Galois representation, elliptic curves in algebraic number theory, or function analysis, discrete geometry, combinatorics, or operations research, stochastics. So you do have a depository of diploma works. I have posted the website of the diploma works, and some of them are written in English. So I think that it's worth looking at this depository. Let me just turn you to Lydia. When you had to choose a topic for your diploma work, how did this happen? Yes.
Well, I first choose my professor, like the one who will be my advisor. Of course, I choose in depending of the topics that I like, which in my case is operations research, as I mentioned. So he had a list of topics, very interesting, because I couldn't choose myself because I really like all these areas. So he gave me a list of topics that he had. So here I want to mention the importance of this Directed Studies course, because based on what we did with Directed Studies, we also choose the topic for the thesis. So we were working at the same time in both projects. So it was really nice. Also because I had the opportunity to work with two colleagues from the University of Bonn in Germany. So we could publish a small conference paper. It was amazing because I have an experience to work with other people from other places, and yeah.
Okay, let me just ask you, do you still work in this area? Because now you finished your master's degree and you are in the PhD. Did you still continue to work on this topic, or you are choosing something else, or you have something else in mind to continue with?
We kept working in the questions that were open from the paper, but also I found another topic which is very interesting for me now. So nowadays I'm working in two projects, which is very interesting, by the way, because sometimes you get tired of working in something, and I can work in both, and this kept me like more focused in both. Yeah.
Okay, I'm glad, and I wanted to say that this is quite typical, that people start working in directed studies and they continue with this project in their thesis, but it also happens that someone works in directed studies in one topic and then decides to continue in something else. Also, it is possible to continue your thesis in your PhD program, but you can also switch subjects. I have seen many examples of that in the past. Okay, so we are done with master's studies in pure mathematics, and let's get to the next program, and this is master's program in applied mathematics. This is for 2 years or so, and the structure is very similar to the pure math program. You have coursework, and you have modeling project work. This is the prototype of actually the directed studies of the pure math program. In this project work, students work on their own with the help of some supervisor, and they also have to write a thesis. The selection of the courses is more prescribed because there are 38 courses. Of course, this is much more. This is double than what they have to do, but it is more guided, in some sense, guided program, that you have to have a certain number of credits from each group, and then you do not wander around too much for choosing your subjects. There are courses in applied analysis, in computer geometry or discrete mathematics or computer science, operations research, and stochastics. Let me just show you two possibilities for a selection of courses in this program. If you would be interested in technomathematics, which is, say, computer science, or combinatorics or discrete mathematics, then you could take a course in algorithms, applied discrete mathematics, codes and symmetric structures, computational geometry, computational methods in operations research, cryptography. But let me just also mention, these are all in some sense parts of discrete mathematics, but probably you would also have to take a course in probability and statistics, or about stochastic processes, linear and abstract algebra, multivariate statistical methods. So this is not in one direction only, but you get the foundations, and also you can go in one direction. The other possibility, for instance, is that you are interested in financial mathematics. And if you are interested in financial mathematics, then probably you will take more courses in probability and stochastics, like analysis of time series, or financial processes 1 and 2, finance and economics, introduction to information theory, introduction to statistical computing. So these are all related to stochastics. But again, you might be interested in partial differential equations. If you want to do some higher level probability theory, you might need it, or stochastic processes as well. Linear and abstract algebra probably is also a good foundation for all of these subjects here. So this is another possibility. We do have courses also in the direction of numerical analysis, so there would be another possibility for someone to choose from. A few words about the modeling project work. I see Professor Zemplin is with us, so he will just correct me if I'm saying something wrong. In this modeling project work, this is similar to the directed studies, and the course concentrates on real practical problems. So we do have some connection to local companies, either research companies or institutions, smaller or bigger size, which come up with some problems for students on which they can work, and they can learn how they will have to work at the end of their studies. And this is basically the process of modeling, that first you have to find an appropriate mathematical model, then you develop the mathematics needed for that, and then perhaps, if necessary, you also do some computer programming to solve the model, or you just develop the mathematics needed for that. And I brought with me some titles from last fall's session of reports. One is concerning three-dimensional reconstruction of using stereo vision, or modeling complex networks using machine learning. And so we have this artificial intelligence subject in the agenda. Cost-optimal condition-based maintenance or vehicle routing problems in real-life application. So as you can see, these are more applied topics, but these are usually coming from real-life problems.
So, István, may I just
yes,
say one sentence? That here in the applied projects, I think computer programming is a very important part of the work. And we offer courses, so preparational courses where our students can indeed learn to write programs in, well, let's say Python or other computing languages which are suitable for mathematical models, and then they can apply their knowledge in real life during these projects.
Yes, thank you for this adding this very important aspect, that computer abilities, knowing how to deal with computers and learning programming, for instance, is very important. And we do offer courses for this. I just didn't include them in the list of selections of the possible courses. Okay, so let's get to the PhD program. We have a school in mathematics with 3 PhD programs, one in pure mathematics, one in applied mathematics, and teaching of mathematics. Actually, I should add that perhaps the first 2 are basically very close to each other, and sometimes we do not know how to decide whether someone is in applied or in theoretical mathematics, because of course many things are applied from pure mathematics, and many things are very theoretical in applied mathematics. So I don't know, Lydia, whether you would qualify yourself as an applied mathematician or theoretical mathematician, but I'm sure that this is not really important. This question is not really important, I guess. Yes. Okay.
Yeah, exactly.
Yes. Okay. So let's get back to this program and see some aspects of the program. Our students do have to take courses in the PhD program, but not much. So the PhD program is, I would say, research-oriented, because it concentrates more on directed studies. You can get credit for research papers or conference talks. You get also credit for teaching if you teach a course. Some people teach younger generations, so you can get credit for this. And you have to write a report on research each year. There is a comprehensive exam after 2 years, and participation at international conferences is really strongly encouraged. I think, Lydia, you can tell something about it. Did you take the advantage of this present situation that now we cannot travel, but we can take part in many conferences? What's your experience?
Yeah, I have this experience last semester. I joined a school in combinatorics. It was held in Germany, but with all this situation of everything is online, then I was able to attend from home, which is it was really nice because I was able to keep with my courses here at ELTE. So it was very interesting. And also, as I mentioned before, I have the opportunity to collaborate with two persons from Germany, which also gives you like a huge perspective of other works from other places.
Of course, this is unfortunately, we have this situation with the pandemic, but this is the advantage of the pandemic, that it is much easier now to join conferences. But even in the past, I think that we had funding for students to support their travel. Okay, so let's get back to our next slide. Let me just find my next slide, and this is some titles of some recent PhD works. Again, I would like just to show the diversity of the people's interest in our program. So a topic in numerical analysis, combinatorics, real analysis, graph theory, differential equations, function analysis, algebraic geometry, group theory, stochastics, differential geometry, number theory. So as you can see, this is a quite a variety of topics for PhD work. The research of the PhD students is supported by the research in the Institute of Mathematics. And of course, much of the research is done on an individual basis, but we do have organized research groups. Some of them are joined with the Hungarian Academy of Sciences. So let me just list here some of them. We have a research group on combinatorial optimization, on large networks and numerical analysis, on geometric and algebraic combinatorics. There is a group in combinatorial geometry. We have a research group for didactics of mathematics, and we have a very applied research group in protein information technology, in bioinformatics. So this research group deals with synthesis of various proteins, but also discusses topics like the connections in the human brain. So this is quite interesting for someone who is more applied-minded. And just something else to add about the research in the Institute of Mathematics. Of course, the events that happen in the Institute are always giving a huge impact on students. And if a conference is brought to them, then this is important. It is also important for our staff members to be part of this international scientific community. So I just listed here 3 conferences from the last 3 years. Unfortunately, I couldn't bring anything from 2020 or 2021 for obvious reasons. But the first one is the 20th European Conference on Mathematics for Industry, with hundreds, I don't know precisely, but I think it was over 300 participants, maybe even more. Or the conference organized to celebrate Professor Lovász's 70th birthday. This was again quite an event for combinatorics. Major names appeared as principal speakers in 2018. Or there was the annual meeting of the European Network for Business and Industrial Statistics in 2019 in Budapest. Okay, so then there are some smaller conferences. I didn't want to list them all. Let me just get further. A little bit about the history of international students in mathematics. Originally in the 1960s, I didn't want to get back any further, but in the 1960s, we had mostly students who would learn Hungarian, and these students would come from third world countries. So the teaching language for them was in Hungarian. Then in the 1990s, we started programs in English, and we also started to participate in European and then worldwide networks of education like Tempus, Erasmus, Cepos. And nowadays we have even more of these programs. And one of them is, for instance, the Stipendium Hungaricum program, which brings to us students from many parts of the world. The teaching language is English. I included Hungarian because we still have some students who come and learn Hungarian first. But in most of these programs, they have full English program. Each term we have something like 5 to 10 Erasmus students, exchange students, and we have 5 to 10 new Stipendium Hungaricum students who stay either for master studies for 2-3 years or for PhD studies for 4 or 5 years. And we have exchange programs with over 25 universities. What kind of programs do we offer to our students besides teaching them in courses, offering them courses? They take also parts in some competitions. The first one is the interesting competition. This is a take-home exam for 10 days with 10 to 12 research level problems. So this is the so-called Schweizer competition. It happens in every October. And this is by some considered one of the most difficult mathematics competitions in the world. The volume containing problems from, I think, 1962 to 1991 was published by Springer. I think the next volume is due to come soon. Or there is this traditional style mathematics competition organized by the London University College in London, but organized in Belgrade. And the team of ELTE is usually among the top 5 university teams. This is an IMO style competition. Students can take part in research projects, so they can get a topic from our lecturers, our professors, and they can work on it. And if they come up with some research result, then usually it gets to a paper which is publishable, or we have student conferences on which these papers are presented, and also some of them end up winning an award. A third part of the program for math students is that we organize international summer schools each year. As you can see, here are the posters of summer schools starting from 2013 and ending at 2018 now. Here, this no, sorry, 19. The last one was organized on topology and geometry and algebra. And the next one should have been the conference in 2020. Unfortunately, we had to postpone it until 2022. This is topics in number theory about ancient problems and recent results. To conclude, let me just mention something about what you can do in your free time. If you have free time, of course, there is a lot of opportunities to go to various places in Budapest, like to concerts, all kinds of concerts, classical and non-classical concerts as well, or theaters, or museums, or you can do sports. There are 47 different sports at ELTE, or you can just go hiking in the neighborhood of Budapest or a little bit further. So I think that I wanted to ask Lydia, how do you spend your free time? What is that you enjoy most?
Well, when I was master student, I joined these swimming classes offered by ELTE, because as you mentioned, ELTE offers a lot of sports to do with a very few amount of money. So that's nice, also dancing. So I was joining this swimming course, but you know, the pandemic was not good for swimming, so they changed to virtual exercises, which was also nice. Also, in my free time, well, I like to study Hungarian. So ELTE also offers courses to learn the language, which I find very interesting, because it's amazing to learn about the culture too. So, but what I like to do the most, and I can do now, is to travel by bike. So Budapest has a lot of nice routes to travel, so you can go and visit different parks and different places of the city and in the surroundings. So that's what I usually do in my free time. Yep.
Okay, so I'm glad I knew that you did some sports, and we also spoke about biking possibilities. Unfortunately, this COVID situation made us all aware of the possibility to use bicycle in the city transport. Okay, thank you. So let me just conclude it with one extra remark with the next slide. What I wanted to mention is that one cannot get over cannot avoid answering some questions about the COVID-19 situation. We had online teaching since March 2020, but hopefully, having in mind that the vaccination ratio in Hungary is over 40% of the full population, and over 20% of the full population already got the second vaccine, we hope to have back to our normal life by the end of the summer. So no one can promise, because of course no one can make a promise in this respect, but by September 2021, we hope to have a regular teaching. Of course, if you come, bring your mask with you, because it may be important. Unfortunately, for a long time, we may have to live with masks. I'm not quite sure, but it's better to be aware of this fact. And my last slide is about some important addresses, which you can find. I think the most important one is about the first one, where you can find links to the others about the master studies and PhD, about the application procedure here. And here you can find also the contacts to some people. You have my email address, or the email address of the Institute, or the email address of the International Office of the Faculty of Science, and this is Miss Eva Knight's address. So actually I'm just turning to Eva because we have another much shorter slideshow to show you about the entrance feature. So Eva, could you just continue now?
Yes, thank you very much. So I will just guide you through the application process real quickly. So to apply, you have to go to the application platform of ELTE, which can be found at apply.elte.hu, which you can see on the slide. And you have to click the sign in by register button in the upper right corner, and you have to type in your email address. After this, you will receive a verification email that allows you to continue the registration process. Make sure that you use an email address that you check frequently, because this will be our main means of communication with you throughout the entire process. After this, you will have to fill in your personal details, add the photo of yourself, and upload your documents that are needed for the application. The required documents can be found on the ELTE's website in the degree finder section, which you can see on the slide as well. You can also find the requirements here and lots of specific information about all the degree programs that are available at ELTE. I highly recommend checking this website before applying, because you might find some useful information there. So deadline to apply to all of our programs at ELTE is, or at least the Faculty of Science, sorry, is the 31st of May. So there is still time to submit your application. To apply to the mathematics or the Applied Mathematics Master's Program, you need a bachelor's degree in mathematics or a related field, such as informatics or some kind of engineering, with at least 65 credits completed in mathematics. You have to upload your bachelor's degree and academic transcripts as well. If your bachelor's degree is still in progress, that's not a problem. You can upload a certificate of your current institute that you are still in the process of completing your bachelor's degree, and you are going to receive it this summer. You should still upload your academic transcripts up to the last completed semester, and you also have to have an English language certificate, which is either, which should be an internationally accredited language examination, or a certificate from your previous university that you have completed your bachelor's studies completely in English. So that can be accepted as well. You also have to upload a CV and a motivation letter to the application platform. And it is also required that you upload the bank payment proof of the application fee before the deadline. The application is very similar for the doctoral school, but in that case, obviously, you need a master's degree in mathematics or a related field. You can upload additional documents that are related, such as conference attendance, publications, but these aren't mandatory. Just if you find it important, then you can upload it. And once you have submitted your application and the application period is over, then we will begin to evaluate your application. And if your uploaded documents fit the criteria, then you will be notified of the entrance examination via email. There is an I will talk about the entrance examination in a bit, but actually once you have been admitted to the program, you will receive confirmation from us and other details regarding the enrollment, about life at ELTE, and lots of other useful information that you need to know. You can also find this information on ELTE's website, like accommodation, health insurance, and everything that will be really useful. So I recommend that you check it out before your application and also after that as well. So yes, you can see on this slide some useful links and my email address as well. But let me just continue with the entrance examination, because this is a frequently asked question about how applicants should imagine the entrance examination. So there is a written examination on June 19th. So if you apply by the deadline of the faculty, then you will receive a note about the entrance examination around the 10th of June. And tests will be sent to you via email on the day of the examination. And you have to return your scanned solution within 6 hours of receiving them. And for doctoral students, there is also an oral part of the entrance examination, which is probably going to be around the end of June or the beginning of July. You can also see some links here that where you can find some sample examinations. So I recommend just checking those out as well. The entrance examination consists of several subjects. Basic mathematics is mandatory, and you have to choose 3 subjects from this list as well. I won't read them all, but you can see them on the slide. As for PhD studies, it's a bit different, but the same system. You have to choose a subject group, so it's basic mathematics and 3 subjects depending on the subject group of your choice. And there are some funding options also available. Some of these have been mentioned before, but there is a Hungarian state-funded scholarship for PhD students who are applying from within the European Union. So it covers tuition fee, health insurance, and some living expenses. The deadline for applications is the 31st of May, and the entrance examination is going to be on the same day that I have mentioned. There is also the Stipendium Hungarian Scholarship Program, which is available for on all levels of studies. For bachelor students, it's only available in Hungarian, but for master's and PhD students, you can apply for the English programs that we have talked about before. And there are close to 80 partner countries in this program, but you can also check on the website of the Stipendium Hungarian Scholarship Program if it is available to apply to ELTE from your country. The Stipendium Hungarian Scholarship covers tuition fee, health insurance, and some of your living expenses as well. And The application period for this one is already over, but for the next period, it's going to be available from around November of this year. So if you are interested in this, then I suggest keeping an eye out for the call for applications starting from September or so, because it will be published sometime in November. There are also some scholarships for PhD students. For example, the Rényi Doctoral Fellowship by the Alfred Rényi Mathematical Institute. This is only for PhD students, and this is a scholarship to cover your living expenses. And the next period of applications will be available in April 2022. And additional support might be available from certain research projects, like some of those that you can see on the slide. I think that this is all that I wanted to say. So we are really looking forward to receiving your application and seeing you at the faculty in September. So with that, thank you for your attention.
Thank you also. Thank you, Eva, and thank you both to Lydia and to András, who was very diligent in answering the questions. Let me just conclude with the remark that you will get a follow-up letter after this event containing the address where you can find the information on this webinar. So this will be posted in the YouTube channel of the university, but I think that it was already posted in the chat box here. But in any case, you will get this letter. If you have further questions, please don't hesitate to contact us and to write us either to Ms. Eva or to me, or directly to the Institute, Mathematical Institute, regarding the program, regarding administrative problems, etc. If we can find the answer to your question, then we will let you know. So I'm glad that you could join us. I'm glad also to my fellow hosts. Thank you very much, and I hope to see you in the fall. Thank you and goodbye.